Hi, this is Rahul Santosh Chaumal, and this video is regarding my research and computational thesis proposal. The topic for my proposal is a semi-supervised ensemble and hybrid model comparison for RUL prediction. RUL prediction as a domain of data analytics is growing widely. It is also it is an important part of prognostic and health management applications. The maintenance of an aircraft engine in an operational condition at an early detection of a possible failure is a fundamental requirement of an aeronautical industry. Condition-based maintenance approach is used in this. So this approach is like the maintenance of a piece of an equipment is made based on the current status and not on the simply the time passed. Hence, RUL prediction is mandatory for a condition-based maintenance system. These systems are usually a complex machines, and if a failure of these complex machine leads to a downtime of the system, and it will impact the productivity. The cost of repairing is also very high, and the time for replacement of these systems is comparatively high. So it is very crucial to develop a failure detection system. The research objective for this research proposal is we are developing a semi-supervised ensemble model for RUL prediction. We are comparing this model with the hybrid ARIMA plus SVM model. The motivation for this topic is that it increasingly impact the predictive analytics, and also from the literature review we have seen that the accuracy of these kinds of model increases by these kind of prediction increases by using a hybrid model. We have also used GRU in against LSTM because GRU is way faster to train, it requires less data, and it is simpler to implement when compared to LSTM. My research question, which I formulated, is can a semi-supervised ensemble model provide a significant improvement in predicting the RUL of an aircraft engine when compared to a hybrid model of ARIMA and SVM? The novelty of this project lies in building a semi-supervised model in which unsupervised model of VAE is used and a double-layered GRU is used, which is not being used in this domain. The novelty also lies in hyperparameter tuning of this model using a Bayesian hyperparametric optimization. So these are few of the literature reviews which we have see, which you can see over here. The most frequent use of hybrid model is using CNN, FNN, LSTM, and there is one more currently which is released few weeks ago, which is using a restricted Boltzmann constant with LSTM for RUL prediction. But the hybrid model of VAE and um, GRU is not been done till date in this domain. So the research methodology which I'm using in this is a KDD approach. This process usually have five main steps. First is selecting the dataset. Second is pre-processing, which requires cleaning and exploratory data analysis. Third is transformation. Transformation requires dimension reduction, normalization, and preparing the data to be readily available for modeling purposes. And then we will be using data mining process, which we will be implementing our model, and then we will be interpreting our results and evaluating using root mean square error, score function, and Diebold Mariano test. So the dataset which we have used in this research is of CMAPS dataset, which is given, provided, and maintained by NASA. So it is basically divided into two parts, training and test. The training part has approximately 1,60,000 of records with 26 attributes, and the test data is approximately 1 lakh of data. So the limitation of these kind of data set that it is labeled, hence it is challenging and time consuming to acquire. So the proposed algorithm which we are using over here is first we will be taking a sample or a percentage of the training data, and we will be training it with a unsupervised variant autoencoder to extract the features out of it and get the local minimum. And once these local minimums are taken out, we will be using it as a weight on in our consecutive recurring units, gradient recurring units. And we have used two gradient recurring unit because it is I have studied in literature review that using a consecutive gradient recurring unit or an LSTM uh, improves in finding the hidden patterns in the data set. And after that we will be using Bayesian hyperparameter tuning to optimize our hyperparameters. The tools which we will be using in this are TensorFlow and Python. So this is our research plan which we will be using, and it can be seen over here that there is approximately 5 weeks of time allocated for building and implementing the model, as it requires huge processing power and time consumption. Since we are doing hyperparametric optimization, the system is also available with us to do that, and we can this will be the basic procedure to do this. And thank you for listening to my research proposal. Hope you liked it.